Right, in this example, we are told that a retail shop has determined that the price demand function for its product, so the shop is just selling one product, is P equals to 10 minus 0.001x, where P is the unit selling price for its product and X is the number of units sold per week. Okay, so the price demand function gives us a connection between the price set by the retail shop and the demand for that product in terms of the number of units they are likely to sell. We're going to explain this a bit below. If the cost of each unit is 2 emalangeni, so they buy each unit for 2 emalangeni, so obviously presumably they are going to need to sell it for more than 2 emalangeni, while the weekly fixed costs stand at 500 emalangeni. So the costs that are not related to the number of sales, things like rent, electricity and stuff. Then find the most profitable number of units to sell per week. So remember, the number of units is connected to the price there. So this is the unit selling price, X is the number of units sold. So alternatively, the question could say determine the price to set to make the maximum profit. So the other thing to note here, most profitable. So here want to maximize the profit. The constraints of course are going to be the costs. So let's talk about the price demand function for a moment. So I've already mentioned gives a connection between the price you set and the demand you are likely to get. So this one, P equals to 0.001x. This is a straight line demand curve. It's going to be down sloping. So the curve is going to look something like this. So P is equals to 10 minus 0.01 x. So if we've got the number of units this side and the price this side, then when the price is okay, for the number of units sold to be 0, the price we need to set is 10. So if the unit price is 10, then the number of units is 0. If the unit price is 0, this side, if you put 0 here, solve for x, you are going to get 10,000 this side, and then it's a straight line. So this thing is saying if you set the price at 5 emalangeni, then the number of sales is going to be 5,000. If you set the price at 4, you're going to sell a bit more. If you set the price at 6, you're going to sell less. Set the price at 8, less. At 9, less. The price is 10, no one is going to buy your product. Okay, and then if the price is 0, if you give, so we're going down here, price is 0, if you give your product for free, then 10,000 people are going to have it, which means this is a market with 10,000 customers or something like that. Okay, so that's the price demand function. Now so in business we need profit, and profit is basically going to be your revenue So that's all the incoming money minus the total costs. Okay. So we are going to abbreviate this P of X, this one R of X, this one total cost. So we're going to start talking about this one. The revenue, we're only selling one product here. So the revenue is going to be the number of units sold, which we've said is X times the price per unit, which we said is P. So it's going to be X times P. However, we have got P in terms of X, so we can write this entirely in terms of X. It's going to be X into 10 minus 0.01 X. Remove brackets, there's going to be 10x minus 0.01 x squared, which you can see is a quadratic. So it's going to be the revenue. Then this shop is going to incur costs. So total costs are going to be divided into two. There is what we call variable costs, and then there is fixed costs. The variable costs are the costs related with the number of units we buy. Each unit is 2 emalangeni. So if we buy 10, it's going to be 20. If we buy X, then it's going to be 2x. So the variable costs are going to be 2x. Then the fixed cost we were told is 5,000. So that's the total cost. So that means the profit is going to be this function minus this function. So the profit is going to be 10x minus 0.01 x squared. Take away 2x plus 5,000. If we open brackets here and simplify, going to give us 8x minus 0.01 x squared minus 5,000. So this is the function we want to find the maximum of, and of course, as usual, the maximum is always going to be a stationary point. So we want to find the first order derivative is going to be 8 minus 0.002x. Second order derivative going to be negative 0.02. Whenever the second order derivative is a constant, it means this curve does not change concavity. So this one is always concave down, concave down, like that. Okay, so for the stationary point, we need to take the first order derivative equated to 0 and solve. So stationary point is only going to be 1. It'll be 8 minus 0.02x equals to 0. If we solve this, we are going to find x equals to 8,000 units. Okay, and since we have determined that the curve is concave down, this is going to give us the maximum profit. Okay, so it gives us maximum, it is not a minimum. If x is 8,000, so we can find the price he needs to set to achieve this from the price demand function. So if we plug in, where is the price demand function? Plug in 8,000 there, that tells us that the price he's going to have to set is actually this gives us 4,000 here, not 8,000. So yeah, make sure you correct it even in a book. This is 4,000, right? So if you plug in 4,000 here, then you find that the price that he has to set for the maximum profit is 6 emalangeni per unit. All right, so yeah, brings us to the end of that example.